Okay, so for this video, we will be discussing the cylindrical shell method. So this is the third method in calculating the volume of solids of revolution. Okay, so in cylindrical method, so still we have an enclosed area, okay, revolved about a certain axis. Okay, so but what we can notice in cylindrical shell method, okay, unlike the first two methods, the cylindrical shell method uses a strip that is parallel to the axis of revolution. Okay, so in cylindrical method, strip is parallel to the axis, okay, of revolution. Okay, so as you can see here, so say for example we have this area, okay, revolved about y is equal to c. So y is equal to c obviously is a horizontal line. Okay, so the axis of revolution is a horizontal line. So as you can see, the strip used is a strip parallel. Okay, so they are both horizontal. Okay, so in the cylindrical shell method, so still we are going to calculate the differential volume, okay, to obtain the general formula. Okay, so as you can see, so if we rotate the strip alone, okay, so I want you to imagine only the strip. Okay, when the strip is revolved about this axis, so what it will form is a cylinder. Okay, so a thin cylinder. Okay, so sorry, that was a hollow. Okay, a hollow cylinder. Okay, so meaning it's hollow. Okay, and then it's thin. Okay, so it's like a shell. Okay, so that's why it's called cylindrical shell. Okay, so what will form is a thin sorry, so a thin shell. Okay, so something like that. So say this is its center. Okay, so it's revolved about that. Okay, okay, so when you rotate this strip, okay, so what you will form is a shell. Okay, and the differential volume of that shell, so say for example this is its radius, okay, and then this is its length. Okay, so the differential volume in this case will be dV is equal to the circumference, okay, the circumference of this multiplied by the length and then multiplied by the thickness. So in this case we'll be using dy. Okay, dy. Okay, so the differential volume will be equal to the circumference. So the circumference of this cylindrical shell is 2 pi r. Okay, and then its length is L, and then its thickness is dy. Okay, so that if you integrate both sides, so you will get, so I'll just write it here, the volume is equal to 2 pi is constant, so we can take that out of the integral sign. So 2 pi integral of RL dy. Okay, so this is the general formula if we have a if we have a horizontal strip. And then obviously if we have a vertical strip, so all we need to do is change it to dx. So v is equal to 2 pi integral of RL dx. Okay, so if we have a vertical strip. Okay, so obviously the same with the two methods, the two earlier methods. So we will identify R and L based on the graph. Okay, so the R in this case is the distance from the axis. Okay, the distance from the axis of revolution to the strip. So this is the R. Okay, and then the length of the strip, that will correspond to L. Okay, okay, so the same method. So say for example, if we are looking for the length L, so in terms of x and y, that will be xr minus xl, right? So the length of that strip, so is equal to xr minus xl. So in this case also, the R, okay, the R is equal to y high minus y low, because this is not in the x-axis. So the distance from the strip to the y-axis, that is y, right? So that is y. But since we are only until C, therefore R in this case is equal to, so in this case, so let me rewrite it here. So the L is equal to xr minus xl. Okay, and then in this case, our R is equal to y minus C. Okay, so because this distance is C, right? So therefore, the R, which is this, is equal to the distance y minus distance C. So therefore, R is equal to y minus C. Okay, so in different positions, so you still you need to apply that concept. Okay, the xr minus xl, and then the y high minus y low. Okay, this is actually y high minus y low. Okay, for us to get the length, okay, R, or the radius R. Okay, so let's apply that to some problems, and let's also compare what if we use the other two methods, okay, instead of a cylindrical shell method. Okay, so for our first example, so the area bounded by the parabola y is equal to x squared and the line y is equal to 2x is revolved about the y-axis. So find the volume generated. Okay, so where's my, okay, so first let us graph, of course, solution. So we have here y is equal to x squared, so that is a parabola opening upwards. Okay, and then we have the line y is equal to 2x, so this is in slope intercept form, so therefore we will have a line with a slope of positive 2, so therefore it's inclined upwards, okay, from left to right. And then it will have a y-intercept of 0, so as you can see, y is equal to mx plus b. So we don't have b, so therefore b is equal to 0. So therefore this line passes through the origin. Okay, and also this parabola has a vertex at the origin. Okay, it has a vertex at the origin opening upwards. Okay, so let's draw those two. So we have a line with a slope of positive 2 passing through the origin. So we have, so let's say, okay, so our line looks like this. Okay, and then our parabola looks like this. Okay, so this line is y is equal to 2x. This parabola is y is equal to x squared. and then it is revolved about the y-axis. Okay, and then what else? We have to find the intersection, okay, their intersection, so that we can determine the limits. Okay, so intersection, so let's solve it here. Okay, so since y is equal to x squared, since y is equal to 2x and y is equal to x squared, so therefore 2x is equal to x squared. Okay, so transposing 2x on the other side, so we will have x squared minus 2x is equal to 0. So factoring x, what will remain is x minus 2 is equal to 0. Equate the factors to 0, so therefore we'll have x is equal to 0 and x minus 2 is equal to 0. So at x is equal to 0, y is equal to, so substituting either here, so substitute y is equal to 0, x is equal to 0 or x is equal to 0 here, so we will have y is equal to 0. So here x is equal to 2, and then therefore y is equal to, if we substitute 2 here, we will get y is equal to 4. If we substitute 2 in here, we will get y is equal to 4. So therefore, 4. So the first point obviously is the origin. Okay, the first intersection is at the origin 0, 0. The second point is at 2, 4. So coordinates here is 2 and 4. Okay? Okay, so let's solve this in two ways, okay, so that we can compare which method would be easier. Okay, so first let us solve this using the method for this video. So let's use the cylindrical shell method. Okay, so in the cylindrical shell method, again, you remember that the strip should be parallel to the axis of revolution. So since our axis of revolution is vertical, so therefore our strip must also be vertical. Okay, so this. Okay, so if our strip is vertical, therefore we will have dx as our integrating variable, because that is the thickness of the strip. Okay, and then for cylindrical volume, again, its formula is v is equal to 2 pi integral of r l and then dx. Okay, so we have to find our r. Okay, so the r in this case, so since we are revolving about the y-axis, so the r will correspond to the distance from the y-axis to the strip. Okay, since that is along the x-axis, therefore that is x. Okay, so our r is equal to x. R is equal to x. Okay, our L on the other hand will be the length of the strip. Okay, so this length. Okay, so that length is equal to y high minus y low. Okay, so L is equal to y high minus y low. Okay, so the y defined by the higher curve, okay, is the line, okay, because the upper end of the strip touches the line. Okay, so therefore yh is equal to 2x and yl will correspond to the curve at the lower end of the strip. So this is our yl. Okay, so minus x squared. Okay, so this is therefore our r and our l. So substituting that in our general formula, so v is equal to 2 pi integral of r is x, l is 2x minus x squared. Okay, dx. So the limit of our x is from our graph from x is equal to 0 to x is equal to Okay, so therefore its limit is from 0 to 2. Okay, so integrating that, so we'll have v is equal to 2 pi. Simplify first, I distribute first, so we have 2x squared minus x times x squared x cubed dx from 0 to 2. So v therefore is equal to 2 pi. So this is integrating this, so this will be 2. Integral of x squared is x cubed over 3, so this will become 2 over 3 x cubed minus integral of x cubed is 1/4 x to the power of 4. Okay, from 0 to 2. So substituting the limits, so v is equal to 2 pi. Substituting the upper limit, so we'll have 2 over 3 times 2 cubed minus 1/4 times 2 to the power of 4 minus, if we substitute 0 in the first term, it will become 0, and then 0, so minus 0. Okay, so our v, so we can use our calculators. So we have 2 thirds times 2 cubed minus 1/4 times 2 raised to the power of 4. That is 4 over 3, and then multiplied by 2 pi, so times 2, so we'll have 8 over 3 pi. Okay, so this is in cubic units. Okay, so that is its volume. Okay, so let us compare that with what if we used the ring method instead. Okay, so what if we use the ring method? Okay, so let us solve this problem. So using a horizontal strip, okay, by using the method of ring. So let's draw that again. So we have a line, and then we have the parabola. Let's extend the line. Okay, so their intersection is at what was that, 2, 4. Okay, and the origin, right? This is y-axis, this is x-axis. The equation of the line is y is equal to 2x, and the equation of the parabola is y is equal to x squared. Okay, and then this is revolved about the y-axis. Okay, so if we use the ring method, therefore we have to use a horizontal strip. Okay, so the strip should be perpendicular with the axis of revolution. Okay, so therefore we will have dy as our integrating variable, and then in the ring method we need the inside radius and the outside radius. So the inside radius would correspond to the length from the y-axis until the until here, okay, at x defined by the left end of the strip. Okay, so this is inside radius. Okay, and then outside radius is this one. Okay, so the inside radius, okay, the inside radius will be defined by x at the left end of the strip, so that is xl. Okay, and the outside radius will be defined by the x at the right side, okay, xr. Okay, so at the left end we have the x in terms of y. So if we have y is equal to 2x, therefore x is equal to 1/2 of y. Here also, if we have y is equal to x squared, therefore x is equal to square root of y, or y raised to 1/2. Okay, so our xl, therefore, which is the inside radius, will correspond to x is equal to 1/2 of y. So this is our xl, and then this is our xr. Okay, so this is xl again because the left end of the strip touches the line, while the right side touches the parabola. Okay, so xl is 1/2 of y, and then xr is y raised to 1/2. Okay, so that is our inside radius and the outside radius respectively. So therefore, from the general formula of rings, so volume is equal to pi integral of outside radius squared minus inside radius squared dy. Okay, so volume is equal to pi integral of outside radius, that is y raised to 1/2 squared, minus inside radius, that is 1/2 y, also squared, dy. So limits from y is equal to 0 to y is equal to 4. Okay, so therefore it's from 0 to 4. Okay, so v is equal to pi integral of, so let's simplify this first, so y raised to 1/2 squared, so that is square root of y squared, so meaning it's y, minus 1/2 of y squared, so 1/2 squared, that is 1/4, y squared is y squared, from 0 to 4. So now we can integrate each term, so v is equal to pi integral of y dy is our formula, that will be y squared over 2, okay, or 1/2 of y squared, minus, we have 1/4 multiplied by the integral of y squared dy, so that will be y cubed over 3. Okay, from 0 to 4. Okay, so volume now is equal to, substituting the limits, pi, substituting the upper limit, so we'll have 1/2 times upper limit of 4 squared, minus, we have 1/4 times 1/3, we have 1 over 12, and then y cubed, so we have 4 cubed. Okay, minus, if we substitute the lower limit of 0, we will get 0 for the first term and 0 for the second term. Okay, so therefore volume is equal to, we have pi, what we have here is 16 minus 16 divided by 2, so that is 8, minus 64 over 12, so 64 over 12 is 16 over 3. Okay, so subtracting 8 minus 16 over 3, that is 8 over 3. So this is still in cubic units. Okay, so we still obtained the same answer, right? So in our first method where we used the shell, so we obtained 8 pi over 13. Oh, sorry, 8 pi over 3. Okay. For the second method, we also obtained 8 pi over 3. Okay. So, but their solutions are, the difficulty of their solutions are different. Okay. So, I think the method of shell for this problem is easier, okay, because look how simple the integration was. Okay, so unlike the first method, okay, where our we started with a complication about this one, so we have we were forced to express x in terms of y, So in this case, it was easy to express x in terms of y. So, but that is not always the case. Okay, so therefore, you must decide what method are you going to use. Okay, which method among the three methods? So which among those three methods, okay, is appropriate, okay, and easier to use, okay, so whenever you solve solids of revolution problems. Okay, so I think that's it for this example. Okay, okay, so for our second example, so we have the region bounded by the parabolas y is equal to negative x squared plus 7 and y is equal to x squared plus 5 is revolved about the line x is equal to 2. So find the volume generated. Okay, so first step, of course, is again to plot the curves, the two parabolas. So okay. So yeah, so first let us try to see what our parabolas look like. So we have y is equal to negative x squared plus 7. So that is a parabola opening downwards, okay, with vertex at, if we transpose 7 on the other side, it will have a vertex of 0 and positive 7. Okay, also if we set x is equal to 0, y is equal to 7, right? And then it's so therefore its vertex is at y is equal to 7, and then the parabola is opening downwards. On the other hand, this one, it opens upward, and its vertex, if we set x is equal to 0, it's y is equal to 5. Okay, so therefore it's a parabola facing each other. Okay, so say we have y is equal to 5 here. Okay, and then y is equal to 7 there. Okay, so our graph should look like this. Okay, so where the parabola facing downward is this, so you have y is equal to negative x squared plus 7, and then the parabola facing upwards is y is equal to x squared plus 5. Okay, and then we revolve it about the line x is equal to 2. So x is equal to 2 will be here, and then x is equal to 2, and then it will be revolved about this axis. Okay, and to solve for the limit, so let's find the intersection, okay, by equating. Okay, equating x squared plus 5 and negative x squared minus negative x squared plus 7. So you have x squared plus 5 is equal to negative x squared plus 7. Okay, so let's transpose. So we have x squared plus 5 minus x squared minus 7. Oh, sorry, this will be plus x squared. Okay, and then minus 7 is equal to 0. So we will have 2x squared minus 2 is equal to 0. So factoring this, so we'll have 2 times x squared minus 1 is equal to 0. So then we will have 2 times x plus 1, x minus 1 is equal to 0. Okay, so equating the factors to 0. So this is absurd, 2 is equal to 0. So it's absurd. And then x plus 1 is equal to 0 and x minus 1 is equal to 0. So therefore we'll have x is equal to negative 1 and x is equal to positive 1. So we can solve for y, but I don't think we can use that in this problem. So in this problem, we're going to be using the shell method. Okay. So for a shell to work, so the what do you call that? The axis, the strip should be parallel with the axis of revolution. So in this case, we will be using a vertical strip because our axis is a vertical line. Okay. So from the formula of shells, so we have V is equal to 2 pi integral of R L. So in this case, we'll be using dx. RL dx. Okay. So where our R, okay, that is the distance from the axis to our strip. Okay. So this distance. This is our R. Okay. So our R can be solved by we have here xr, okay, minus xl. Okay. So from the y-axis, sorry, we haven't labeled. Okay. From the y-axis to the strip, the distance is x, right? And then from the y-axis until the line x is equal to 2, the distance is 2, right? So this distance here is 2. Okay, so therefore the length of R is equal to 2 minus x. Okay, so R is equal to 2 minus x. RL, on the other hand, okay, is the length of the strip. So it's equal to y high minus y low. Okay, our y high is defined by y is equal to negative x squared plus 7, and our y low is defined as y is equal to x squared plus 5. So therefore, L is equal to y high minus y low. So y high is equal to negative x squared plus 7 minus y low of x squared plus 5. Okay, so therefore, so we will have 2 pi integral of R. Our R is 2 minus x. Then our L is this. So our L is negative x squared plus 7 minus x squared plus 5. Okay, dx. So limit of x from x is equal to negative 1 to x is equal to 1. Okay, so this x is equal to negative 1, and then here x is equal to positive 1. Okay, so let's simplify this. So we will have 2 pi integral of 2 minus x times, so this will become negative 2x squared, and then 7 minus 5, that is plus 2. Okay, dx from negative 1 to, okay, so from negative 1 to 1. Okay, so next is we can simplify this, we can distribute, okay, or we can factor out negative 2 in here. Okay, so it depends, or you can just directly distribute. So integral of 2 times negative 2x squared, that is negative 4x squared. So 2 times 2, so that is plus 4. Negative x times negative 2x squared, so that is negative, that's positive 2x cubed. And then negative x times 2, so that is positive, that is negative 2x. okay, dx from -1 to 1. So in this case, we can use the properties of odd and even functions so that we can integrate this. We have odd functions, this one and this one, and these two are even. Okay, so we can separate them. So from 2 pi integral of -4x squared plus 4 plus 2 pi integral of 2x cubed minus 2x dx. So they are both from -1 to 1, from -1 to 1. So since this is an odd function, okay, the 2x cubed minus 2x, so this is equal to 0. And since this is an odd function, then we can change the limit from 0 to 1, but we will multiply the whole integral by 2. So this will become 4 pi integral of -4x squared plus 4. Okay, so dx, sorry, there was a dx here, from 0 to 1. Okay, so applying the power formula in integration, so this is simply 4 pi integral of -4x cubed, so that 4x squared, so that is -4 over 3x cubed plus 4x, okay, from 0 to 1. Okay, so substituting the limits, so we'll have 4 pi, substituting the upper limit, -4 over 3 times 1 cube plus 4 times 1 minus, substituting 0, so you will get 0 plus 0. So we'll have 4 pi, and then this will become 4 minus 4 over 3. That should be -4 over 3, sorry, negative 4 over 3 plus 4, okay, times 4. Then fraction, so we'll have, we have 8 over 3, so we'll have 32 over 3 pi. Okay, so this is cubic, so 32 over 3 pi cubic units. Okay, so if you have tried another method for this, if you try another method for this, so say for example you will be using a ring again. Okay, so if you use the method of rings, then you will have to use a horizontal strip. Okay, so but the problem with using a horizontal strip is that, so you have the parabola like that, okay, upwards and then downwards. Okay, so if you use a horizontal strip, okay, so when you use a horizontal strip, as you can see, the right end and the left end of the right end and the left end of the strip is defined by the same curve. Okay, so this is the same curve, right? So if you will use that, it will be a little bit complicated. Okay, because this will be defined by positive x, and then this will be defined by negative x. Okay, you can still do it, but it's still it will be very difficult. So aside from that, you will also need to divide the area into 2. Okay, because the strip on the other side, okay, the boundaries of the strip, okay, will be different again. So this is the y is equal to, what was that, -7x squared, negative x squared, sorry, y is equal to negative x squared plus 7. The other one is y is equal to x squared plus 5. Okay, so as you can see, okay, when you go from bottom to the top, okay, so as you can see that it will change. Okay, the boundaries of the strip will change here in the middle. Okay, so if the boundaries of the strips will change, therefore you should divide the area. Okay, so it will be much more complicated, okay, if we use the method of um, rings. Okay, so so the method of shell, okay, is an alternative, okay, if the method of ring is too difficult, okay, to solve. Okay, so just like in this example. Okay, so the process of using a horizontal strip will be very difficult. Okay, so but if we, yes, it's difficult. Okay, so maybe we'll try that out on some other videos, but I think this video is taking so long. Okay, so but you can try it on your own, okay, to solve this problem using method of rings. But as I've said, it's quite difficult. Okay, so whenever you encounter such problems, so you should be able to decide what method are you going to use, okay, so that you can evaluate the volumes easier. Okay, so that's it, and that's the end of the topics for the topics of the solids of revolution.